First it might be. Do we need to put like empties for the record?
Hi, my name is Matthew Smith,
My name is Chris Ranc.
And my name is Shabab Siddiq.
and our project is the automatic cat feeder. The automatic cat feeder is an Internet of Things based cat feeder, which can be programmed using an Android application and distributed across multiple feeders in order to work well with many animals that you may have in your house. The goal was to be able to program in which animals you have and how much you want them to be fed via the Android app, and the feeders can take it away from there. The primary feeder carries most of the information about the pets, including the age, name, and the amount it needs to be fed. It will also log when the animal gets fed and control feeds by the secondary feeder.
Secondary feeder is a much simpler device. Once plugged in, it'll automatically detect the wireless network broadcasted by the master feeder, communicate with it to get key verification, and then continuously commute to it once it detects a pet to ask if, am I allowed to feed this little guy?
In the master feeder, we use a Raspberry Pi, which we use to both access a managed local network such as your home Wi-Fi, and also put out its own access point so that the secondary feeder and the app can connect to it for initialization purposes, and it keeps the internal communications on a separate network just for security and ease of use. The secondary unit uses an ESP8266, which communicates back to the Raspberry Pi whenever it receives information about a pet wanting to be fed. It talks to the main feeder and makes sure that the pet's allowed to be fed and gets the information on how much to feed. Aside from the primary controllers, both units are identical, which allows it to be easily duplicated and multiple units to be made. On the technical side of things, the main or leader unit uses the Raspberry Pi Zero W. Already mentioned was the dual network capabilities. It uses full use of the GPIO and specifically the SPI standard. Under the hood, it uses a Flask HTTP server communicating to MongoDB to hold JSON documents that holds information about each pet, different feeders connected, the feed logs, and any other information we may need to store. It uses a multi-threaded application server so that it can continuously check RFID reads and feed and everything else that needs to be done without having to slow down or stop. The secondary unit uses many of the same things, but using the ESP8266 uses MicroPython. MicroPython server, which acts as a more minimal Flask server, and in many ways it does similar things to the main unit.
So the server application that's loaded on the ESP utilizes a modified version of the PicoWeb framework, which utilizes the async IO library that's a part of MicroPython.
Here we have the primary and the secondary feeder, using a chassis that was designed in Autodesk Inventor and then laser cut using the Construct's utilities, and 3D printed augers, gears, and a gear retainer connected to a stepper motor. We have two nearly identical devices that can feed food from the hopper and detect the mass using a load sensor. The animals are detected via RFID tags with an RFID reader in the front, and then everything is synchronized via the app. The feeder works by first the cat will walk up, it'll usually sniff the bowl, and then the RFID will read. Using the RFID tag, it knows which animal just walked up, and then we'll cross-reference that in the database with however much food it needs to feed. The feeder will continue until, with anti-jamming technology, the feeder will continue. Yeah. Come on, bud.
There's no food inside.
There totally is. Alright, nice. Yeah, with anti-jamming technology, it will not jam completely. It might make a scary noise, but it'll continue to feed. It will feed until the load sensor detects enough food has entered the bowl, and then it will stop automatically. Same thing goes for the secondary feeder, but each cat cannot feed at any feeder. this tag will not work, but this tag will.
It detects it.
So here, that specific cat was able to feed at the secondary feeder, but the first cat was not. Both feature inconvenient anti-jamming technology, and both will stop you at the same level. The load sensors are configured the same way, so that everything stays consistent across the board. Now we're going to talk about the Android application.
Okay, so for the Android application, the way it works right now is that this is your main screen, so you can see the cat here for all that. So in order to connect to it, you just hit connect feeder, and then for now it's a direct connection, so you just put the IP address in. You get prompted to do that. And then when you hit the connect button again, you hear a meow, that's how you know you're in. And then you see a list of all your cats, so you'll see one like Sniffles, Mark, and like JLo for example, and you can see the name, age, weight, serving size, which feeder it's assigned to, as well as its feeding schedule for the current day. So for example, this cat was assigned to the main feeder, this one goes to any, and this one goes to a supplementary feeder, so you can assign which one it goes to. So to see for more information, you hit the view full pet information, so you can see all the information right here. You can see its current schedule for today, or you can select it for every single day as well, so you can basically see the feeding schedule on the day that you want. What you can also do is that you can also add feed times as well. You can set it to be either a daily feed time, or you can specify which day you want. So let's say today is Wednesday, right? So then I can set a feeding time to, let's say, 2:30. Let's set that one. I don't want to give it a 45-minute feed window, so well, maybe let's make it like a half-hour one actually, or 15 minutes. Let's go with 15 minutes. So we can add the feed window, and you'll see that it will return. And if you go back for today, you'll see that it just added the 2:30 p.m. to 2:45 p.m. feed window over there, and everything it constantly refreshes everything, so it's in order based on the earliest to latest time. If you want to remove a feeding time as well, you just select a feed time, and then you hit the delete feed time button, and then just wait for it to refresh. And then you'll see that it's no longer in the system. And let's say something happens to your pet, you want to basically update the information, you go into the edit pet button. You can basically change the age of it, you can change the weight of it as well. You can also reassign what feeder it goes to. For now it was at the main, so I'll change it back to be any. So then when I'm done with there, I just hit the update pet button, and then I'll go back. You can also set the RFID tag from this menu too. So yeah, this is basically the pet information that you see right there. So if you go, you hit the back button, and you can basically go back to any of the pets. You can also, let's not add pets, but you can also remove pets from the pet profile page. You can add pets from the main menu as well. So.
Right now this RFID tag is programmed to a different pet, so it is not privileged to feed at this feeder. But we can easily configure the RFID tag to the cat JLo, and when we do that, we hit the config, it sends a message, and the next RFID read will program it to be this new pet. And so, now it should configure, and now it feeds.
All right, so now for your engineering requirements, we'll just go through them one by one. A, software to track multiple animals and differentiate behavior based on animals being served.
That was able to be seen in the Android application.
B, database to store data from mobile app that presents in human readable format.
That's the database stored on the Pi talking to the Android application.
So does an admin or something have view of that database, or?
Yes. Not the direct database, but through the user interface on
Just the app.
application. Yeah.
Okay. C, wireless operation aside from power to prevent curious animals from chewing on wires.
No wires.
D, ability to wirelessly communicate to supplementary devices that act as simple feeders while the master unit manages smart feeders, so we saw the supplementary unit in action. E, supplementary and master feeders respectively need a controller with wireless peripherals or peripherals to integrate with a wireless module. They both work. F, high capacity food container of at least half a gallon.
This is 2 quarts. I don't remember my elementary school conversion tables.
2 quarts would be half a gallon, yeah.
Awesome.
G, precise dispensing control. Dispensing depends on food size, but it ranges from 8 millimeters to 18 millimeters.
Mm-hmm. So this is on the small scale for the food, and it can accept larger kibble if need be.
Stop jamming, hopefully.
H, long-term reliability for automatic feeding for at least a week.
As I've seen with how much my cat feeds, this would be able to hold that much, and using the anti-jam technology, the cat would eventually be fed.
I, dispense food within 5 seconds of detecting a pet near the feeder. Seemed to work pretty quickly.
This was almost instant.
And I think that was your last one. So a couple of questions about your project. If you were going to do another version of this cat feeder, would you start off with what you got right now, or would you go back to the drawing board and do something completely different, or some kind of hybrid of those?
I think it would be a bit of a hybrid between them. We would definitely need to start fresh with the physical design, be it the hopper all the way through the auger and the motor chosen. The electronics were by far the most sturdy and reliable aspect of this, and a majority of the trouble we found was due to the actual dispensing mechanism. If we had someone who understood mechanical design better on our team, maybe those hitches wouldn't have been caught. But if we were to start over, we'd definitely start fresh with the actual dispensing mechanism.
One that I had during my time developing for the ESP, MicroPython is very useful, but one of its limitations was the object size of code. So, since Python is a little bit more bloated than, say, a low-level language like C, it reduces the amount of RAM I'm able to use. So I might consider changing to a different controller and switch to using C, because as we had to add more features, it made it difficult to make sure there was enough to be able to add features, because as I would add more features, it wouldn't be able to run everything, and MicroPython would fail due to not having enough memory.
Okay. Anything about the app, or?
I think it was, I think I might go about revising the overall design for it too, as well, I guess. As far as the libraries were concerned, I had some trouble working with the OKHTTP library, but again, it was just more from lack of experience working with Kotlin, Android Studio, and those libraries. So if I were to go back, I would probably start from scratch and have a better design going forward, and just revise it now that I'm a lot more comfortable with the tools and environment.
Sure.
So,
So you already kind of mentioned this a little bit in the answer to that question, but what in the project, based on now versus what you were anticipating the end of last semester, went really smoothly and unexpectedly? You thought it was going to be more challenging, and what gave you a really difficult time that you thought was going to not be so hard?
We were able to set up a majority of the electronics for prototyping very quickly. We were able to set up the drivers and have everything talking within a few weeks. The most worrisome part was getting everything fitting together. Initially, we were going to 3D print the chassis, and as time was going on, we realized that would have been a big detriment, both design and time. So we opted relatively late to switch to laser cutting. And the hopper was a much bigger detriment, much bigger difficulty than we anticipated. We thought food would fall easy, but it does not like to fall easy. You guys have anything?
No.
You got it.
All right. Anything else you want to say about your project?
I hope it doesn't scare the cats away.
It's either a nice, comforting purring sound from the motor, or it's scary. I don't know which one. All right. Thank you.